everyone. Thanks for taking the time to join us today on our webinar. So we're going to get started. Okay, so today what we're going to do is we're going to cover a presentation based around our relationship with Altair. So the product that we've been selling for Altair for a number of years have started to come to fruition, and we've got a lot of different amazing relationships with different customers. And today what we want to do is give you some knowledge about this amazing relationship we do have with Altair, but also with our customers. So we're here to go over a bit of a collaboration with ourselves and one of our customers, who I'll introduce in just a minute. So today we're going to be going over the development of, or should I say reduction of the production time during development for one of our customers. So today I'm going to be presenting with Harshal. Thankfully he's here to give us his experience of the Altair SimSolid product. So a quick introduction to myself for anyone who has never met me before. My name is Cheryl Snedden. I'm part of the consultancy team at Symmetry for MFG, and these days I'm working quite a lot with the simulation products, and also still delving into the advanced manufacturing products as well. Harshal, do you want to introduce yourself just now, or?
Oh, yes, of course. Good morning, everyone. Yeah, my name is Harshal Kulkarni. I am working with Modulift since the last 5 years. I work as an engineering manager with them. So basically a brief introduction about Modulift. So Modulift is a lifting specialist company. We are into manufacturing of standard plus customized lifting products. We have got like a wide range of lifting products which are pre-designed. They are third-party certified, type approved, and they are always in stock because we have got like a wide range of distributor network as well all around the world. So we supply our products almost in every part of the world. So coming back to Symmetry and what was our relationship with Symmetry is that as a Modulift, we are always keen to introduce or like perform an high-end engineering and state-of-art engineering at a Modulift. So Symmetry came through as a breakthrough with their product called as SimSolid, which is a finite element analysis software which has got a very user-friendly, and you can say like a familiar design engineering process module, what a typically design engineering process involves. Okay, so let me start with my presentation and go through how
Harshal, what I'll do is I'll go over the agenda just to let people know where we are, and then I'll skip through and we'll get to that in just a quick minute.
Sure, no worries. Yeah.
Thank you. Thanks, Harshal.
Right.
Okay, guys, so what we're going to do today is we're going to do a bit of an introduction to Altair and Symmetry. For anyone on the call who already have some knowledge around the Symmetry background, I'll just explain a bit more about that relationship we have with Altair. A bit of background on what SimSolid is, some information around the product, and then I'll hand it back to Harshal and he'll go through his extensive experience with the product and give you a bit of a live demo. And then after that, I'll give you a bit of a demonstration on some of the things that we've been working on in regards to virtual connectors inside the software. I just want to give you a bit of an idea of the kind of approach that Altair take towards their customers. So I'm just going to show you a quick video, guys, just to give you an idea of where Altair are coming from in terms of their their business.
The conventional wisdom says that to achieve something new, we must work within established boundaries, parameters, silos. That the size of an idea is determined by how much it pushes its limits. So what happens when there are no boundaries? What happens when the barriers separating creativity from analysis are removed? When we can refine ideas as quickly as we dream them? When insights emerge from an ever-growing sea of detail? What happens when we're no longer constrained by the limits of the physical world? We are Altair, and these are the questions that drive us. To bring together the most powerful forces in technology, across every domain of humanity, throughout every mode of industry, we enable innovative minds to advance infinitely, to change tomorrow together, to find out where innovation will take us, when instead of testing the limits, we remove them.
Okay, so hopefully you were able to see that video, everyone. Harshal, are you still there?
Yes, I'm there. Yeah.
Yeah, just checking that everyone can hear me.
Yeah,
Okay,
definitely.
Okay, so just some information about what SimSolid is. So this is our main focus today, is obviously Harshal's been using the product and for a while. So this is some information about what SimSolid is. So SimSolid is primarily a structural analysis tool based around FEA, finite element analysis. So it's a bit of a game changer in the technology. We've got a lot of customers who might be using different products, who have a lot of time spent preparation of their geometry, including mesh. So SimSolid actually eliminates that geometry preparation and the meshing. There is a case for multiple design scenarios where you can build different design studies and analyze in different ways. There's no need to simplify the CAD geometry, and it supports typical connections like bolted connections, rivets, things like that. Any connections that you've got. A lot of the geometry you would create within the CAD environment might need to be stripped back, but we don't need to do that with the SimSolid product. So at the bottom here, the last step that we've got there is the types of analysis that we can do within the software. So primarily linear static, but we do have modal, thermal, but we also have more complex non-linear and transient dynamic effects as well. Okay, so it was just to give you an idea of what we can do inside the software. So this is another slide, guys, just to give you an idea of the complex models. So we can work around things like 3D printing, additive manufactured, lattice structures, organic structures, as well as building structural frames, welding fabrications, bolted connections, and then basically the time that it takes to produce those results is rapid. And we'll see that today. Obviously, Harshal's got some examples, and I'm going to be working through an example, so we'll see those results and we'll see how quick it takes to run those results. So I'm going to pass you over to Harshal, and he's going to go through his experience of the software.
No problem. Thanks, Cheryl. Right. Yes. So let me start my presentation.
Fantastic. Yeah. We can see your screen, Harshal.
Oh, amazing. Okay. Yeah. Right. So, okay. So yeah, as I gave my introduction about Modulift, so basically we have a wide range of lifting products. We are into a specialist lifting industry. Like our tagline suggests working between the hook and the load. So basically, it is the products which we supply are linking between the crane hooks and the actually load which is lifted. So the products can be of a nature like such as spreader beams, lifting beams, depending on structural actions are required. So, and depending on the customer requirement, we customize the products also, wherein the role of SimSolid comes into picture. Yeah, it's working now. Yeah, yes.
Yeah, perfect. Thank you.
So yeah, sorry. So that's a design and engineering process, which is typically followed at Modulift, or I would say in general as standard engineering companies, which they follow a design and engineering process. So I think the first step always is a analytical modeling. What we do is the modeling of the structure, what we want to design or analyze, that's there. So the next step would be the defining of the material and geometric properties. Then we add the design specifications, apply constraints, apply loads and displacements, and we solve the analytical model. All these steps I would just go through in a bit more detail in few of my next slides. So just going forward. So the analytical modeling, I think, so usually it is done in a 3D modeling software. So there are numerous softwares available where you can do the modeling through which the analysis model is prepared. Then it is interfaced with the analysis software. So SimSolid has got a very good interface with software such as SolidWorks and Inventor, like that. But at Modulift, we use SolidWorks as our main design package. So when we onboarded SimSolid, it was very swiftly integrated with SolidWorks, and the model imports was absolutely seamless. Then model cleanup, which we used to perform in our earlier FEA softwares, but in SimSolid it is not required. So the interface being very smooth, we just import the model straight away onto the SimSolid platform. So now defining the material and geometric properties. So SimSolid has got a good extensive material library, as well as we can define the materials in the 3D modeling software, where it is defined, and when it is imported into SimSolid, you get the same material, so there is no mismatch of the material. The subgrade is not essential, because since we are not performing a code check design, we are just performing a finite element analysis. So the stress plots is crucial compared to the allowable stresses on a particular material subgrade. Okay, going forward, adding the design specifications. So I think this is a crucial part in any FEA software, is defining the connections and then the contact between the various structural members. Regarding the specific behavior of the member, since we do a lifting analysis and our models are usually integrated with slings and shackles, so the definition of sling becomes very crucial for any lifting analysis, which is performed through the tension only feature of SimSolid, as well as the other structural softwares what we use. The modeling of bolts, like Cheryl showed the example of bolted connection, we haven't specifically used as on. It is still under our research of onboarding SimSolid for the bolted connections, but I'm sure we would be successful in doing that. But we have successfully done the weld analysis in SimSolid, and it gives a very promising results and very accurate results, and it gives you the real-time weld behaviors, wherein we can decide on the specific areas where the weld needs to be focused or weld can be optimized or avoided, which in turn helps or optimizes our fabrication and manufacturing process as well. The next step is applying constraints. So we add various kind of supports depending on the requirement, the structural requirement. Additionally, we can add partial supports or weak springs where the sling and shackle connections or interfaces are there. So which is a very key feature in the lifting analysis. Then applying loads and displacement. Again, this depends on the structural requirement of the analysis and design needs to be performed. We can add the displacements in a form of constraint as well. So like we can specifically restrict a certain displacement, which I can more elaborate in the design model or designs what we have performed, which I'm going to show you in a short while. And then solving and then reporting the results. So we can get the stress results, deformation plots, and animation. So I think these three are the key features of, or the key results what we are interested in. Animation is also very important. It gives you the behavior of the structure, and which enables us to understand whether the structure is behaving in the correct manner based on the inputs what we have provided. So this is one of the design example which was performed during our product development stage. So this is one of our product which we sell quite a lot at Modulift. And the feature of this product is it can give you a lifting capacity at a very long spans, because when you require a very lightweight lifting tool at extremely long spans, then our spreader beams have got a limitation. For that, we use the lattice as a lifting solution. As you can see in the model, it has got a large number of connections, high number of members, and even more number of weld to be analyzed. And if we try to analyze this as a part of FEA or any other FEA software, it is going to take hours and hours of first preparing the model, then creating all the inputs for FEA, and then performing the analysis. Whereas, so that's the main theme of our webinar, is that it was extremely, the design time was extremely optimized when we perform this analysis in SimSolid. So let me just quickly run through on the actual SimSolid and show you some critical information about this design and how it was beneficial by using SimSolid. Yeah, yes.
Perfect. We can see your screen,
yeah.
Harshal.
No problem. Yeah. So yeah. So like I mentioned, that the key feature and which was not required. So basically, the design process which I explained, it is a standard design process which we use in any analysis where we use in any 3D structural analysis software. So using that process, if we can get the FEA results, that is going to be extremely beneficial, and SimSolid does enable to do that. Because when I was doing an FEA with my engineering team, I think they used to avoid doing that because of a long process duration very high technical content and high technical training required. But when we follow our usual design process, and SimSolid integrates it so well that you can perform FEA on any structural model or any analytical model by using a standard design process. So going forward, this example was created using a 3D model imported from SolidWorks. So as you can see, the lattice model which is here, it is already created in SolidWorks. The elements created in SimSolid were these welds. So they were generated in SimSolid by using the connection design module. Yeah, the seam weld. Yeah. So basically this, by using the seam weld feature, these welds were generated in SimSolid. And I think they were extremely efficient to generate this welds. It took us like less than 1 hour to create all the welds and all the constraints on the model. And the model was ready to be analyzed like in less than an hour's time. Going forward, this lattice had to be applied some specific constraints at the joint locations. So which were applied, yeah, just to maintain the continuity. Yeah. So these were the loads applied onto the lattice, which is like a uniformly loaded, and the constraint was applied on the center of the lattice to maintain the continuity. Then the slings were modeled as the rigid members here, and so that they will act as the tension only member as explained earlier. And there was no meshing step because SimSolid doesn't use the meshing tool. It has got the adaptive solver, so that step was completely eliminated, which takes in other softwares the most of the time. And then this model was ready for a run, and I can show you. You see, the total runtime was 34 seconds, as against any other software would take at least, I would say, 30 minutes to 1 hour to run a model of this scale. I mean, you can see the assembly I can show. It has got 1,391 parts, and all these parts were analyzed in a time of 34 seconds, and the results were what we require. So basically I can show you, yeah. So basically the stress results, I can show the stress areas. So our permissible material grade was S355. So you can see, yeah. So the areas of interest were easily highlighted. So you can see these welds are getting overstressed. You can see these welds are proving critical due to the main lifting lug. So we need to target these specific areas, increase the weld sizes. Additionally, you can see the weld sizes which are not heavily stressed, we can reduce those. So additionally, in a way, we can optimize the fabrication time by optimizing the weld sizes and focusing on the welds which are stressed beyond the allowable limit, and the analysis was performed. So by using your basic design and engineering input knowledge, you can perform an FEA with a very accurate analysis, I would say, in a very accurate manner. So you can see even the animation can be seen, so that you will understand whether the lattice is behaving in the correct way. Yeah. Yeah. So yeah, so this was the lattice example. I can show you another example wherein we have done let me go through that. Yeah. So basically, this analysis was also performed in SimSolid. This was also one of our customized product, what you can say, and it involves geometric as well as material nonlinearity. So let me go through that with a SimSolid demonstration. Yeah, see the model.
Yeah, Harshal, yeah, we can see your screen.
Yeah, no problem. So yeah, so basically this is a analysis done on a thick tube section wherein a sling is wound around it, and you can perform this analysis by using the basic design inputs. So the first, this assembly again was imported from 3D software such as SolidWorks. The connection was kept as the bonded connection on the contact face between the sling and the trunnion. Then a fixed support was applied on the ends of the trunnion, and forces were applied onto the slings. So a simulation was done as the trunnion tube is fixed on its sides and the sling is pulled, yeah, in this direction. And then we wanted to find the stresses in the tube arising out of the sling forces. So again, all the inputs were ready, and we just ran this model for the stress analysis. So again, this is the main advantage, that you have to just give the basic design engineering inputs and you get an APA results within seconds. I won't say not even minutes. So you can see the total runtime was like 1 second. So going to the stress plots. So the contact analysis was performed with a very, very high precision and accuracy, as you can see here. Looking at the animation, you can see the tube is getting crushed. So the behavior is as expected, and then the deformation plots. Yeah, so the sling deformations is almost negligible. Yeah, but the main areas of interest was the stresses on the tube, wherein you can see how the tube is behaving here. Specific contact points can be picked. Yeah, you can see these points were picked, and then the stresses were analyzed, and then according to the stiffening of the tube was done. So despite being a complex nonlinear geometry with basic engineering inputs, basic design engineering inputs, and an extremely quick runtime, this analysis was performed, and our product development was completed within a week's time. So that's our experience with SimSolid, and it has brought a high level of efficiency into our design and engineering process. I think that's it from me, and yeah, thanks a lot, folks, for listening.
Thank you very much, Harshal.
To my experience.
I like the Strunion one. I haven't seen this one, so it's really good to see such a simple process to set it up, but it's such a powerful result, to be fair.
Yeah, absolutely. I mean, you can see there were just like 3 sets of inputs we have to give, and then the complex geometry is just solved within seconds. Yeah, so our product development was completed like almost less than a week's time, because we have got like a range of around four different sizes of trunnions, four to 5 different sizes, and all the analysis was completed in a day, and the complete product development was done like less than a week's time.
Fantastic. And just out of curiosity, to let other people know on the call, Harshal, we went through some training just to make the guys aware. Obviously, the training that we did was a short period of time. Did you feel that that was enough for the team to get them up to speed?
Yeah, at the moment, I think it's working well. We are happy with the content what you have covered in the training, so that's all working well. We have been doing the weld analysis and the critical analysis of the critical design areas, and there has been some quite a lot of optimization has come in.
Fantastic.
Yeah. I think and you are quite responsive anyways. If any queries, the engineer they just contact you, and we get a response like within a day, or even within half a day.
Yeah, we try to make sure that we cover as much support. We do have support, just to make you all aware, we do have support through ourselves. So if you purchase a product, it's through us or through Altair, but we have that close relationship anyway. So what we'll do, Harshal, is I'm going to go through a quick demonstration myself, just to give the guys an idea of some virtual connectors, and then we'll come back for another few questions and stuff before we finish up. Thank you again. Just pick the correct one. This is also a relative example to lifting equipment. So I'm going to import in some Parasolid file just to give you an idea. So this is a lifting spreader beam that Wazim's going to be using for some of his training content. So watch out for the next book. You know what Wazim's like. So yeah, with this one here, I'm just going to show you how to build up a basic kind of a virtual lifting simulation to analyze the deformation of the bars in this spreader beam. So whenever you're prompted with the automatic connections, it's quite a simple process. There are not, there's very minimal amounts of parts in this assembly. So what we're going to do is we're just going to run it with a gap and penetration of 1 millimeter. Now, like I said, there's not many parts within this, but the process that we take is quite extensive, but the results are produced really quickly. So the first thing we're going to do is focus on creating those connections between each of the pad eyes. So if you imagine this is going to be lifted with one sling, but there's going to be 4 connections coming from each of the corners of the pad eyes and connecting to one main loop, and it's going to be lifted with lifting equipment. So to replicate that, what we tend to do is we go through a process of adding some spots onto the corners, then we add some grounded bushings, and then we add some cables, so virtual cables. So you will have seen in Harshal's example that he actually modelled in the static frame. But in this instance here, we can do it without the frame being modelled as well. So this is just another example to give you an idea how it works. So I'm going to zoom into these corners and just focus on placing some spots. So again, this process is based around the capture of the spot on the top face. This allows us to then place in the cables at each of the corners. So we're just creating 4 spots, moving them to the location. I'm just being very rough with these just now, just to give you a demonstration of what it will look like. But again, with us, whenever we're working with you guys as new customers, we tend to do some of the work for you up front so that you can see real time your own product with these types of setups. So obviously when we started to chat with Harshal in the beginning, we took his example and we built some of the analysis for him, and then we gave him it back so he could analyse that, and then obviously from there we did some tests back and forth. We spent a lot of time together, and that's the type of thing we do with SimSolid if need be. So we're just going to add some virtual connections now. So the virtual connectors that we tend to use in this instance is bushings. So we're going to place some grounded bushings around the circular pad eyes. We're going to change the coordinate system for no other reason than we like to make sure it's the same one as the global coordinate system. We're going to do that at each of the sections. So this is just basically grounded connections that we're applying to make sure that when we put the height in for the sling, they're coming from a grounded static face. So we're picking the face on the inside. I'm just going to delete that out because it's the wrong one. And again, we're just placing in that coordinate system. Got one more go at this end. And everyone's examples will be slightly different. But in this one, I thought it would be good just to see that you can actually put it in as virtual connections as well as actual modelled slings. So one more thing to do here, we just need to place in the cables. So we're going to place in the cables, and the cables are going to come from the spots that we applied in earlier on. So we're going to pick the grounded cable. You're going to see a dotted dashed line which represents the cable. We're going to place it at a height. Now this height's determined upon the cable size and length. We're going to make it rigid. It goes up to that point. We're going to apply it, and we're going to do that in each of the corners. And again, it's a representation of the height, so that we can get all of those cables up to one point. So we've got 2 more left to do. By that, I'm going to come into the last one. Again, same value. And then from there, you can see on the left-hand side in the tree, we've now got our cables that have been added. And if you imagine in a real world scenario, that would be lifted from that point through the pad eyes. So from here, we're just going to do a structural analysis. So structural linear. From here, I'm just going to apply my force displacement. So that's going to be applied to the surface underneath in the circular, just to represent the weight down, the force down, and the minus y. So we're going to put a value of minus 20,000 newtons and click OK. So that's us got our setup. So basically from there, we created the spots, we created the grounded bushings, we created the cables to represent the slings. Then we created the structural analysis, and now we're ready to run the analysis. Let's just make sure material specified. That was a rookie mistake, sorry about that. But obviously we do need to have a material. I think, let me just run that one more time. Yeah, there's something missing from the structure. I think it's just, let's just take a quick look at this. I think we've got everything that we need in place. Yeah, what I'm going to do is just show you the one that's already been done. So the results are already here with this one. And if we look at the information for the results, you can see it runs in 3 seconds. And when the results come out, they look something like this. And again, we use the animation. We can use our maximum and minimum points here. And we can see that the displacement is in or within the range that you need it to be in. But it was really just to give you an example of how to set it up in such a way where you don't have the model. Not everyone's going to have the model of the sling. It's quite a difficult model to have. But obviously if it's static, it's a bit easier. So you could see in Harshal's example, it was a bit more straightforward. But yeah, I think I just clicked through the example too quickly. So this is the result to show you how it works, guys. But it really does, it works in such a quick way. There is no need to go through the process of mesh convergence. It's going to be a significant tool for you in your toolbox, as Harshal explained during his example as well. So I'm just going to nick back to the presentation. Just let me know if you can see my screen. Can you see my screen all right, Harshal?
Yeah, I can see.
Perfect. So just a quick conclusion for everyone. Thank you very much for being here. Just some points to take away. So again, we spoke about the results that come out in seconds and up to minutes, depending on how complex the geometry is. Analysing that large scale assemblies, eliminating the geometry for simplification. Short learning curve. Again, we tend to be able to teach you how to use SimSolid in a day, and that can be split up into 2 sessions. There's flexible licensing structures, so if you need some information about licensing, we can definitely help you out with that. I'm going to put up some details for myself and Wazim on the last slide. And there is also a 14-day free trial for SimSolid. So if you were interested and you had a project coming up, you might want to use the 14-day free trial with our support. So again, if you get in contact with myself or Wazim, or even if you know your account manager through Symmetry, then you can get in contact with your account manager and they'll pass you through to myself or Wazim. Okay, so I just want to say a huge thank you to Harshal for being here today. It's been really insightful to hear about his experience with SimSolid.
No problem. Thanks, Cheryl, for the opportunity.
No worries, no worries. If you've got any questions in the future, guys, or if you have anything that you want to ask about any of the Altair product line, then please feel free to get in contact with myself or Wazim, or like I say, your account manager should be able to pass you on to us as well. So if you've got any additional questions or anything like that, feel free to contact us afterwards. It's been an absolute pleasure. Thank you very much for your time, guys. Thanks again, Harshal.
No problem. Yeah, my pleasure.